you know, for lack of a better word, everything that we've been covering so far have been about 2 atoms at most, where we have a positive and negative atom. Or in the covalent compound, it is about 2 atoms that are bonding together, sharing electrons at most for a covalent compound. But as I'm sure you are already aware, there are a lot of compounds that have 2 atoms in them, you know, an A and a B. But there are a lot more compounds out there that have more than 2 atoms. And they could have 3 atoms, 5 atoms, 10 atoms, 20 atoms, all bonded together to make one compound. And it's important for us to know that there are larger compounds out there and larger ions out there, because really in our everyday world, most of the stuff we interact with are much larger than 2 atoms bonded together. Okay? For example, your RNA, DNA is one massively huge compound, and it is yours compound, and it has, I don't know, millions upon millions of atoms bonded together, okay, to make your unique DNA, RNA. And technically, your RNA is one compound, your DNA is technically 2 that are closely bonded together, okay? And so it's important for us to know that there are larger compounds out there, and so that's what we're going to talk about today. We're going to talk about how these larger compounds are interacted, bonded together. And so you guys have these notes. They're honestly 5 slides, I think. It's not going to take me long here at all, but we are going to do a little bit of practice today with polyatomic ions so that we understand how they work. So on your weekly schedule, you have the check-in, you have some quick notes, and then we're going to do some practice today, and then we're going to start reactions tomorrow and Wednesday. Okay, what do I want to do? I want to share my screen. Share the screen here, polyatomic. Go to quick presentation mode. You guys are getting this as well. All right, so polyatomic ion. It is exactly what the word sounds like. Poly. Poly means more than one. Polygon, multiple sides. Polytheistic, multiple deities, multiple lords and gods and things like that. I don't know, there's other poly words out there. But poly means more than one. We've been talking about ion being a metal and a non-metal. But sometimes there's more than that, okay? Sometimes there's a lot more than that. The other thing that we have to keep in mind here is the word ion. So remember, somebody give me a quick definition. What does ion mean? We talk about a positive ion, negative ion. What does that mean? Oh, come on now. When you guys interact, when you guys talk. What is an ion? What is an isotope? The word that we should be familiar with. Huh? Okay. Okay. All right. So an ion, when we're talking about one atom, it's an atom that has an uneven or a different number of electrons, but then it has a charge. So if it's a positive ion called a cation, that means that it had fewer electrons. It got rid of the negative, it became positive. If it is a negative ion called an anion, that means it had more electrons, it gained electrons, and it became negatively charged. So when we're talking about polyatomic ions, we're talking about charged particles, positive or negative, but this time they have more than one atom. Okay? It makes sense, it still works, okay? It's not crazy rocket science or anything like that, but in a polyatomic ion, you have the wrong number of electrons, right? You either have not enough, you're positive, or you have too many electrons, you're negative. Okay, in a polyatomic ion. So they are ions that consist of more than one atom, poly, and they have a charge. So for example, nitrate. Nitrate is nitrogen, oxygen, and 3 oxygen put together. Okay. Now, real quick, and let's go ahead and get out the paper pencil real quick. Let's try to connect the dots for nitrate and see what happens. So you have a nitrogen and 3 oxygen. What happens when you try to connect the dot for nitrate? So go ahead and take a couple minutes there. And I tell you what, I'll get out my little drawing pad thingy. What happens when you try to connect the dot for 1 nitrogen and 3 oxygen? One nitrogen, 3 oxygen. What happens when you connect that? So again, try to connect all the single dots. You cannot connect the pairs, so don't do that. But then see what happens when you try to connect them. And you're going to have to get creative with this. This is not a happy element. It's not a happy compound. This is an ion. You're going to have to get creative. What happens here to a nitrate? I'm going to open up my whiteboard here. Man, they're having fun over there. I don't know what they're learning about. They're learning about something fun. All right, so nitrate, nitrogen and 3 oxygen. Try to connect all the dots. What happens when you do that? Does it work? Can you connect all the dots? All right, so what happened with nitrate? All right, so remember, in a nitrate, they're all sharing electrons. Nitrogen has 5 dots. All right, so go ahead, draw this with me. Nitrogen has 5 dots. Draw it with me. Then we need 3 oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, remember, single first. 1, 2, 3, 4, 5, 6, and then double. All right, so this is not going to be a happy compound, but that's okay. I can connect the dots. All right, connect the dots. Nitrogen is happy. Nitrogen done. Oxygen, yes, they can bond together. Remember, we have oxygen gas. Oxygen can bond together. Okay, that does work. But everybody's happy, everybody's satisfied, except for this oxygen over here. So in order to make this oxygen happy, what has to happen? What does that oxygen have to do? It has to gain 1 more electron. So oxygen needs to gain 1 more electron in order to be satisfied. And then, so what we could do is, for example, maybe sodium sodium can give the oxygen that electron. And we end up with sodium nitrate. You see what I've done there? When I connected these dots, the oxygen was not happy and needs one more, which is why nitrate is a -1 charge. It needs one more electron in order to be satisfied. What's that? Not, I mean, yeah, it can exist as an ion all by itself, but only when it's given an extra electron. So let me erase this real quick. The only downside to this app is I don't love the erasing tool. So this compound here won't exist in nature because it's not happy, it's not satisfied. Right? This compound will not exist in nature because the oxygen is not happy. So the only way to make this exist is if I give this electron or this oxygen an electron. This would exist. This is a happy compound. If you give it one electron, it's a happy compound. So the question is, where does it get that one electron from? Well, sodium, potassium, lithium is going to be the easiest way to give it an electron, right? So lithium could give it an electron. Sodium can give it an electron. Hydrogen can bond up with it. Rubidium can give it an electron, right? There are elements that can make this ion happy and satisfied, and all the dots are connected, so to speak. Okay? So nitrate all by itself won't just exist. Somebody or something's going to have to give it an extra electron, and that's why it's called an ion. Okay? Ions are not satisfied until somebody loses, somebody gains an electron. So this nitrate needs to gain an electron first. Let's see where it goes from there. All right, so nitrate is covalently bonded between the nitrogen and the oxygen. They're sharing those electrons between nitrogen and oxygen. And so they behave as one unit. They behave as one thing, as one ion, but they have more than one atom in them. Okay? And so therefore it is treated as an ion. So these are a couple of different ones here. You do not need to draw all these, but if you drew them, you would realize that they are not happy, they're not satisfied. Right? If you drew these, you'd be like, wait a minute, something's going on here. And that's why they're polyatomic ions. So nitrate is nitrogen bonded to oxygen, 3 of them. It needs one more electron. That's why it is -1 charge. And we just drew that to prove it. The oxygen needs one more electron. Carbonate, CO3. When you draw all the dots, carbonate needs 2 more electrons to be happy. Okay? Just like oxygen all by itself, oxygen has 6 valence electrons, it needs 2 more. Carbonate, when you draw it all, it needs 2 more electrons to be happy. Sulfate, SO4, again, you draw that, it's going to need 2 more electrons, 2 more bonds to be happy, to be satisfied, to have all the electrons that it needs. Chlorate, ClO3, it needs 1 more electron to be happy. Hydrogen carbonate, bicarbonate, it needs 1 more electron to be happy. Acetate, it's a bigger one. C2H3O2, it needs 1 more electron. And again, you can draw that. Draw it, connect the dot, and you will see I need 1 more dot. I need 1 more connecting when you draw that. Okay? Cyanide. Cyanide needs 1 more. hydrogen like to bond up with cyanide, you get hydrogen cyanide. Hydrogen gives that extra electron. You get hydrogen cyanide, which is a very common poisonous gas. It is in apple seeds. Don't eat too many apple seeds, but it's also in almonds. It's in a lot of food. But that hydrogen cyanide would prevent animals from eating the seeds so that you can have seeds for the next plant. Okay, so animals will eat the seeds, spit them out, and then the seeds grow in the plants. Ammonia. You guys probably have some ammonia in that home, but you guys have what's called probably ammonium hydroxide at home, and that is Na4+. Now look at that one. That one's positive charge. So that one does not need one more. That one needs to get rid of one to be happy. All right? So again, if it is -1, -2, -3 charge, that means it needs to gain 1, 2, or 3 more electrons. If it is positive charge, it means it needs to get rid of 1, 2, 3 electrons, if it's positive. And then the last one, very famous, is hydroxide, OH. It needs 1 more electron as well. Very common compound for that is sodium hydroxide. Sodium gives the electron to hydroxide that it needs. There you go. You can also get hydrogen hydroxide. That's not really the name of it. But I can put a hydrogen on there, and what do I make when I add a hydrogen on there? Now I have 2 H's and an O. H2O. Water, right? So if I add a hydrogen to that, because again, it needs 1 more electron, -1. It needs 1 more electron. If I add another hydrogen to it, I get water on it. So again, if we go back to the drawing real quick. Again, I wish I would do either way. Racist. All right. But anyway, if I go to the drawing real quick, and I have oxygen and hydrogen, I still need 1 more electron. So this is an ion, -1, called hydroxide. Hydrogen and oxygen, okay? And I need 1 more electron to make that happy. That could be a hydrogen. That makes water. It could be sodium. Okay, that makes sodium hydroxide. Right, so again, hydroxide, oxygen, and water, or hydrogen, it needs another electron to go in there. All right, so the thing about naming though, the naming as always when we did it in the past is that the positive ion, the cation, the metal come first. Same thing in this situation. The positive ion, the metal come first, and then the last name. I do not expect you to memorize these, okay? But if I gave you this table and you bonded up sodium with chlorate, it would be called sodium chlorate. If you bonded up lithium with sulfate, it would be called lithium sulfate. Okay, so the positive, the metal come first, and then the negative come next. And notice that most of these are negative charge on them. Okay. Again, these are polyatomic, more than 1 atom. We got some freshmen over there. They're studying for their test tomorrow. Freshmen. All right, now polyatomic ions, how to write them is exactly what we did before when we crisscrossed the charges. Remember that as a shortcut. All right, it's got to be an easy way to erase all this. Yeah. I'll make another one. All right, anyway, for ionic, let me crisscross the charges. We're going to do the same thing for polyatomic ion. So again, if I have sodium and it's +1, and I have carbonate and it's -2, okay? If I have those two charges, I'm going to crisscross them. The 1 is going to go down here, and the 2 is going to go down here. Na2, CO3. I'm not going to put a 1 on there because that's going to look like a 31. All right? But I only need 1 CO3, so I can just leave that as CO3 with 1. Now, what happens if I have something like magnesium? Still getting used to the drawing tool. What if I have something like magnesium and hydroxide? When I do this, I need to put the 2 down here and the 1 down here. So magnesium, sorry. So magnesium is going to get 1, and then the OH, 2. However, hold up, on that OH, I need 2 OHs. So I'm going to put a parentheses here. The O is going to get 2, and the H is going to get 2. Everything inside those parentheses are going to get 2 when I do that. Okay? So let's do some practice together real quick, and hopefully it'll make a little bit more sense. If you go back to your weekly schedule for today, there's a nomenclature worksheet, and you guys can just make your own copy of this. Okay. So what this is doing here is this is telling you what to bond up with what. Let me walk you through how to do this. So in table number 1 here, we're going to do Ca bonds up with OH. So that is calcium bonding up with hydroxide. So do me a favor, you're going to need your notes, you're going to need your names here. Okay, so make sure you have your name. Let's do a couple together real quick. So question number 2, what are we going to bond together for question number 2? So find number 2 in the table up above it. What are we going to bond together for number 2? We're going to bond together Ca with Cn. All right, now the Ca is going to give the Cn2. Cn is going to give the Ca1. Crisscross the charges. So we need a Cn to get 2. And we do need to practice our subscripts here, okay? Ca is going to give the Cn2. Cn is going to give the Ca1. And that Cn is cyanide. Okay? And so we just made calcium cyanide. And again, gotta look at your table here. Calcium cyanide, right there. All right. Let's try number. Let's try number 17. What's that? Yeah. Let me see if I can zoom this in a little bit. A little better. You guys see that a little better? All right. So the little 2 down here came from the calcium. The calcium in the second group. 1, 2. The Cn the cyanide can give the 1 because it's a -1 charge. There's not a 1 up there, but it's a -1 charge. We don't need to write 1 in chemistry, so it's -1 charge. So you're going to put a parentheses around a CN because the calcium is giving CN 2. Okay, C and N, carbon and nitrogen, are getting 2 on there. So we're going to put parentheses around that. All right, so let's do 17 real quick. What are we bonding together on 17? So we're going to bond together Na and phosphate. PO4 3-. I'm going to put subscripts here for that. I have to crisscross my charges. Phosphate has a +3. Going to get a 3 to sodium. Sodium has a phosphate is -3. Going to give 3 to sodium. Sodium has a +1. Going to give 1 to the phosphate. So the 3 needs to go to the sodium. I'm going to put a 3 over here. Again, I'm going to do my subscripts for that 3. Okay. And then the phosphate is going to get a 1, which means I don't need to change it. I don't need to change phosphate if it's going to give it a 1. If I was going to give phosphate a number, I would put parentheses around it and give phosphate a number, whatever number I wanted to give it. Okay. And then that is sodium phosphate. Let's see. I want to try one a little bit harder. Let's do number 12 together. What am I going to bond together for number 12? So Al and SO4 sulfate. So let's go down here. I'm going to put Al and sulfate together. Al is +3. It's going to give 3 to the sulfate. So sulfate needs to get 3. So I'll put parentheses around sulfate because I want everything in there to get 3. Just like in math class, you put a number around the parentheses, everything gets multiplied by that number. So for sulfate, there's aluminum, going to give 3 to sulfate, and a sulfate is going to give how many to aluminum? Sulfate -2, sulfate is going to give 2 to the aluminum. Okay, we're crisscrossing the charges non-stop there. So the aluminum is going to get 2. And again, I'm going to do my formatting here for subscripts. For my subscript, then that gives me aluminum sulfate. That makes sense? You guys with me on that? Are you sure? These are essentially the reactions that we're going to be doing in the future. I put aluminum with sulfate and see what happens. You know, like you can mix these two together and see what you make, see what you form. Okay. All right, so let's try number 3 again real quick for us. So number 3 here, we're going to put calcium with bicarbonate or hydrogen carbonate. Okay, so I'm going to put calcium, and then I'm going to put HCO3. Calcium at 2, it's going to give the 2 to HCO3. I'm going to put parentheses on that and get all 2 on there, okay? So calcium is going to give 2 to the carbonate, bicarbonate, and the bicarbonate is going to give 1 to the calcium, so we don't need to write that 1 on there. Again, make sure we're doing subscripts. And then we have calcium bicarbonate. I'm curious how you guys are doing. So I'm gonna walk around a little bit. I'd like for everybody to work on this. Kids at home, let's try to get all the way down number 10 done. I'm gonna walk around, kind of see how you guys are doing. But this is our work for today and tomorrow, so it's not a big deal. You know, we have about 10 minutes, so I don't expect you guys to finish this. This is due on Friday, but I'm gonna try to get as much done as we can. Kind of see how you guys are doing. So let's try to get 10. We'll try to get 1 through 10 done right now, and then we do a little bit for homework, a little bit tomorrow. For number 4, that is an L. Sorry, that's chlorate. That's chlorate for that one. Right? So number 12, you're putting down aluminum with sulfate. Again, you're gonna need this table here to help you. I don't expect you to know those names. I don't expect you to memorize them. Okay. I will give you the information, but you guys need to use the information. You need to find it. So there's that information there. That's aluminum and carbonate on it, or sulfate. There it is. All right, I'm going to stop the recording.